Hi, my name's Carl Wilson. Welcome to my channel and welcome back to my workshop. So, I've returned. I had to end up doing 5 weeks instead of 4 weeks at work. I did a little bit extra, but I'm back now and normal service has been resumed. So you will have seen from the title of this video that we're going to have a look around the M250 VFD setup today. By VFD I mean variable frequency drive. I know most of you know what that means, but there are some people watching, perhaps English is not their first language, so we'll just make that clear for them. And Jack Body, one of my subscribers, asked me in an email some time ago if I would show you the VFD setup on the lathe, and so we'll do that. I've got a couple of little repairs to do, nothing too major. You'll remember last time when we did the setup for the gearing for the 5 Acme thread that we needed to find somewhere new to put the tachometer sensor, the pickup. So we'll look at that, and also the speed potentiometer on this machine needs some attention. I think I need to replace it, so we'll do that as well. And whilst I'm doing those tasks, I can show you how the VFD is set up on this machine and what I've actually done to get it all working. I have something else to show you as well on the workbench, so we'll head over there now and we'll have a look at the item that has arrived while I was at work. Right, let's get over and let's get on with it. So we're over at the bench now, and as I mentioned in the introduction there, while I was at work, this little objet d'art turned up. And you'll remember the issues that I was having cutting the 5 Acme thread for the nut for the milling machine. Well, I cut my losses basically, and I splashed a bit of money, a chunk of change as some people would say, and here we have a nice 5 Acme threading tool made by Carmex, and I've got this via Pro Tools here in the UK. So let's have a look. We'll take this out of its box if I can get it out. Out you come, there we go. So here we have a wholesome chunk of solid carbide goodness. Nicely ground, it says on there. I think it says 5 Acme, let's have a look. Can you? Yeah, 5 Acme, there it is. And it's got a hole for through coolant. Not that I'm going to use that, but you know, could be handy for some people. Titanium nitride coated. It's been ground to give us some clearance, and obviously, I mean, all the angles are going to be correct. I don't need to check them. This is going to do a good job for me. Yeah, I agree, expensive just to cut one thread, but I want to get it done. I don't want the project to be held up by this 5 Acme nut. So I've already spent quite a lot of money doing other things, so you know, it's no big shakes really. I just want to get the job done, and this is most certainly going to achieve that for me. I think what I'm going to do with this is I might potentially make a holder for it to for that to slot into, or with a couple of grub screws to put this into the Dixon tool holders. We'll see. I mean, it might just go in like that, like a boring bar, but yeah, we'll see. So I'm going to have some experiments with that and cut a test thread. I think potentially what I'll do is use Delrin instead of the aluminium, because it was pointed out to me by Fast Druid, it actually was, that I could get a pickup on the tool of a bit of aluminium, could weld itself, and that could destroy the whole thread before we, you know, before we get any further on with it. And that's not something I want to happen. I want to try and make a test thread so I can prove that the tooling works. So Delrin seems like a good fit for that, for that reason, and it'll give us a chance to practice and make sure that we've got the depthing correct and everything else. I can't seem to get that to focus for you. All my videos are out of focus, aren't they? Yeah. Anyway, so there you go. We have the tool for the job. But before we employ this, as I said earlier, I've got a few issues with the lathe, and we're going to have a look at that in a minute and see what we can do about it, and also show you the VFD setup. Now, I want to talk about, just before we do that, this again. You'll remember from part 4B of the mill videos, I was looking at this, and I was looking at how these the flanks had torn, but also the roots, so the depthing of the roots was unbelievably wide, and I couldn't work out what had gone wrong with it. And what I think is that the tool that I ground up to do this from that old solid carbide, brazed carbide rather, threading tool. No, it wasn't a threading tool, was it? It was actually a grooving tool. But anyway, it doesn't matter. What I think has happened here is that, as was pointed out to me by another gentleman on the MIG welding forum, whose name escapes me, but I will give him a mention and I will give him a name check and credit for what he said, is that I think I might have ground the helix angle. I forgot about the helix angle essentially of the thread when I ground the tool, and I didn't make enough allowance in the grinding of the tool for the helix angle. And I think what's happened is, as we've begun to cut the thread deeper, that the side of the tool has begun to foul as the helix angle has developed and the threads got deeper. And that's what's caused this width anomaly. Anyway, that to one side. Let's get over to the lathe now. I'll show you the VFD setup and we'll do some, get rid of some of these little anomalies and issues that we've had with it. Okay, so we're now looking at the control panel of my Harrison M250 lathe. And those of you who know these machines well will have realized by now that this is not the original control panel that the machine was built with. I tried to use the original control panel and keep everything as stock when I installed the VFD onto this machine, but unfortunately I was unable to do that and get the functionality that I wanted out of the VFD. So I had to build this panel with these various buttons and controls on it to make it do what I wanted it to do. And I tried to sort of put it together using controls and switches and a look that was in keeping with the sort of the look of the machine, being a mid-80s British machine tool, the kind of controls and buttons that were used then, and try to get it to look like it's meant to be on there, and a sympathetic installation, I suppose you'd say. So going from left to right here, what we've got, using my first best pointer, this is an Eaton isolator. So this is the main isolator for the 240 volt supply coming into the machine, and there's two supplies coming from this switch. I'll show you once I take the panel off and we're inside there. Basically, one 240 volt supply goes to the single phase motor on the coolant pump, because I should also explain that this machine was a single phase factory original when I got it. It was in a school where they didn't have three phase, so they'd specified a single phase from the factory. So it was a capacitor start and run motor that was on here to begin with before I put the 240 volt three phase motor on. So inside the original control cabinet, or the original control panel rather, there wasn't any three phase equipment, it was all single phase. So next we have the all important emergency stop button. The original didn't have one on the panel here, excuse me. It just had the kick stop and the stop button, so I've installed a separate emergency stop button that locks. Obviously it's you have to twist it clockwise to unlock it or to reset it. Once it's been pressed in, it mechanically locks in place. Buttons in, buttons held, basically. Here is the tacho display, which obviously at the moment is not working because I disconnected, or rather I removed the tacho pickup from the vicinity of the magnet on the shaft, on the spindle of the lathe. When I was, you'll remember from part 4B or part 4A rather, when I put those change wheels on, I had to move the pickup. This switch here is to operate the coolant pump. So basically on, off, on. So the old one was on, off, on. So I basically it was the switch that I could get that looked right. So the bonus was that I was able to replicate that on, off, on functionality that the old one had. It was probably the only switch they could get at Harrison's as well back in the day. This switch here is the forward, reverse and stop switch, and this is quite handy, and I'll show you why that is in a second. These two green buttons here, obviously go buttons, they're the jog buttons that allow me to run the spindle at the lowest frequency that the VFD will output, regardless of what setting we've got on the gearbox. That'll give me the lowest frequency. So The jog speed varies depending on what speed setting or range you've got on the gearbox, but it's generally pretty useful, that actually. So forward and reverse jog. And then we have the start button and the stop button, and this potentiometer in the middle here is obviously the speed potentiometer. This has been giving me a bit of grief actually recently. The detent on it is broken, so it just rotates round all the way 360 degrees and back to the beginning again, which I'll admit is not that big a deal, but it's quite annoying, so I'm going to do something about that. I'm going to replace it. The way this works is that to start the machine we have to press the green button. Once the green button is pressed, nothing's happening, as you can see. We then have to move the forward reverse switch to forward, so once we put it in that position the machine will begin rotating. It's in the lowest gear at the moment, so it's rotating fairly slowly. You'll have to forgive me, it's hard to show you the machine turning whilst I'm showing you the panel, so you'll just have to go by the sound. I'll see if I can get that rectified actually in a minute. So when I move this switch to the center position, that stops the machine, but what it also does is I can stop the machine with this button, and I'll demonstrate that now if I start it again. So the machine's stopped now, but the deceleration parameters between operating this button and using this switch are different. So this allows the motor to slow down gently and almost coast down to a stop, whereas this one stops it much quicker. There's a much more, shall we say, sharper deceleration parameter on this button that I set on the VFD. So it ramps it down much quicker, it's a much steeper ramp down. The purpose of that was so that whilst doing threading, I could almost use this switch as a clutch, or the functionality of having a clutch on the machine. So I could thread up to a shoulder and then stop dead, and then reverse. Once the tool's been moved out of the way or backed off, I can then reverse out, leaving the lead screw engaged all the time. And that was why I set that up to do that. So deceleration parameter on this is much quicker than it is on here. And it's worth saying as well at this point that the emergency stop has its own input on this particular VFD, its own dedicated input, and the deceleration parameter on that is even quicker than this. So when I hit that button, everything stops very, very sharply indeed, which is obviously what you would want. You don't want to get your arm tangled up in something or some digit or part of your anatomy. When you hit that button, you want that thing to stop, and it certainly does. I'll give you a demonstration of that later on. Okay, so the jog buttons, as I mentioned earlier, they run the lathe at a lower frequency, the motor of the lathe, so the lathe runs slower. In order to do that, I need to, if I'm in this position and the machine is running, so let's press the go button. So the machine's running now, and I can stop the machine with the red button, and then I can use the jog to operate jog forward or jog reverse, whichever I want to do. So we'll hit stop again, we'll put that back to center. So hopefully that's given you some idea of how I can actually use this panel to operate the machine and get the sort of functionality that I want out of it. The main thing to take away from it really, I think, is this setup here for the forward stop and reverse, and the rapid stop that gives me for threading, because unlike the older Harrison series machines, like the 140 for example, have a clutch, these M series machines didn't have one. So having a clutch is a definite boon for threading, especially up to a shoulder or some other feature where you can actually stop the machine. And it breaks the spindle as well, so it stops it relatively, in short order. So I've kind of replicated that with this. But what I'll do is now I'll reposition the camera and I'll try and show you this thing, so you can see the chuck moving and see what it actually does in terms of stopping it and the sort of the decelerations that we're looking at. Okay, so I said I was going to give you a demonstration of this rapid stop for threading on the forward stop reverse switch, and I'll do that now. I've got the range set to B3 on the M250, which is 750 RPM maximum, It's going to be doing about 250, I would say, and you'll see the rapidity of the stop. It's easier to show you it when it's doing a fair clip rather than at threading speeds. But you'll see how quickly it stops this way, and then I'll show you it at a more kind of sedate speed for threading. So that's it running, and it stops. Reverse, and it stops. So you can see how quickly it comes to a stop there. So what I'll do now, I'll put it into A2, which is A3 actually, which is 90 RPM. Right, so we'll run it again. So that's the kind of speed I would thread at. I don't thread at 750 RPM like some people do. The thought of it terrifies the living daylights out of me. So there you go, there's your stop. And back, reverse the tool out, stop. So we're threading up to a shoulder, we get to the shoulder and we stop. And that's the functionality I wanted, and that's what I got with this VFD. And you'll see something inside the panel. I had to build a small circuit with some relays to get that functionality, because I couldn't get it by programming the VFD. Excuse me. By programming the VFD itself, I certainly couldn't achieve it anyway. So I managed to achieve it using a bit of relay logic and the VFD as well. So I'll show you that in a minute, and we'll get into the panel. Okay, so hopefully you can see what I want you to see, which is the front panel of the inverter, or the VFD rather, built into the casing on the back of the lathe. Now this is at the tailstock end, just about level with where the back of the ways are, or the rear of the machine, and that's the position I chose to fit it in. And it works quite well. It's not in the way. It's not going to get bumped or knocked as I'm moving around the machine, just generally using it. And now you can see here that you've got, like most VFDs, you've got some controls on the front panel. You've got the small pot there, which is for controlling the speed, and stop-start buttons, forward and reverse. And these controls on the front panel, they're actually disabled at the moment, because I've got the VFD program to only obey commands from the external input and output terminals. So all my controls on the front panel that I just showed you are wired to input terminals on the VFD itself, and it responds to commands from them. So on or off, 1 or 0, or an analog input from the potentiometer with regards to the speed control. So you can see this is a TECO E510, I should say, VFD as well. That's the make and model. And it's a really good machine. I think they got taken over by Westinghouse, so the quality went right up, and it was quite good to begin with, actually. And they're made in Taiwan, I believe, these machines. So what I want to do now is run this up and show you what happens to the display. You can see that we've got a figure of 27.48, which is the frequency that the unit's currently outputting. It's flashing because the VFD is in a stop condition. So when I run the machine, and you'll see that the numbers will go solid, the display will go solid, and you'll see the frequency on there changing as I ramp the speed up and down. So we'll do that now. You might not be able to hear me as I move away, but you'll certainly see the numbers change. So here we go. Slowing down. So we've now got a frequency of 7.38 Hertz, and we'll speed it up a bit now. And we can see now we've got 40.6 Hertz, so we're not far off maximum speed there, which is 50 Hertz. So I'll stop it now, and you'll see those numbers flash. So that was rapid stop using the forward reverse stop button. Yep, so we're flashing, that means we're stopped. So what we'll do now is I'll switch power off to this. We'll take this front cover off, and I'll show you what's inside here. Right then, as the Who would say, we're going mobile. So I've got the front cover of the casing now that the VFD is in. You can see the cutout there that I made so that I could see the controls and the display when it was in the enclosure. And this is the front cover of the terminals, and you can see there it says single phase 220 volt 1.5 kilowatt, and you can also see there it says danger, cut off the power and wait for 5 minutes before inspecting components. They're not joking. There's some pretty big capacitors inside this unit, and if you don't follow that advice, you might find yourself getting a bit of a rude awakening as to the presence of those capacitors. So that's a good safety tip. Right, so let's get down there. We'll have a look at the beastie in its cage and show you some of the bits and pieces. Yeah, so we're handheld, as I said. I hope you can see what's going on in here. There's the enclosure with the VFD mounted in it, and it's stood off the back of the machine or the stand by some nice aluminium tubing standoffs that I made for it. And let me just show you physically where this is in relation to everything else. So there's the bed of the machine, there's the tailstock, and here's the stand, and there's where the VFD is. So it's in a nice place, it's not going to get coolant on it or anything else, and it's not going to get knocked. And so you can see the terminal cover is off here. So here are, and I could put my finger in here because the thing switched off by the main isolator, and I've had it off for about 10 minutes now. Lucky old me, eh? Usually a 3-minute man, but there you go. Anyway, there's the terminals, and you can see these cables coming in from, let's get some light in there. Those cables that are coming in from the control panel, from the various switches and buttons that I showed you earlier, and the emergency stop. Now you're probably wondering what that chocolate block is all about there. Let me try and get the light in position. I have got in here a small voltage regulator. You'll recognize that if you know anything about electronics. That's a 7805 or the 7800 series, and that's a 7805 3-terminal linear regulator. The purpose of that is to take one of the 12-volt auxiliary supplies from this unit to operate some equipment that's actually behind the control panel, and I'll show you that later on when we get into that. So down here you can see the wiring coming in. This side is the motor. Let's get the light so you can see what I'm doing. I'm looking and pointing at. So on the right hand side there, as you look at it, is the electric motor cables, and on the left hand side is the mains coming in, and in the center are all the control wires coming from the panel. I know it looks pretty cramped in there. It looks a lot worse than it is. There's actually plenty of space for those cables in there, and you can see how I've run the mains cable and the motor cable, and also the control wiring. It's in this screw-in conduit. So these glands here, they're through the box with a nut, and then this conduit that looks like it's got this rough kind of coarse thread on it, that threads into this part of the gland. So this is really good stuff. It makes it completely waterproof and completely coolant proof as well, so there's no dust or dirt or liquids going to get into there. And there's also a gasket around the casing when the lid's on that protects the VFD. And just as a point of order, let me get the light back up here. I like to see these units personally. I like to see them inside an enclosure. I know people say this is an electrical enclosure. No, it isn't. It's got cooling vents in it, it's got grills, it can get dust in it, it can get dirt in it. They're not supposed to be mounted on a wall. If you want to do that, that's fine. It's your workshop, do what you like. Personally, I'm not going to do that, and it should not be done like that. They should be in an enclosure. This is an electronic component. It needs to be in a box. This box looked pretty small, but it's the right size for the unit. It doesn't take up too much space. There's plenty of venting holes in this box, in this enclosure, for the fan to get a good draw for the unit. I've never had any issues with overheating or any other problems. I should have mentioned earlier, actually, if I were to have any problems, this is where I would look for them. The LCD display there, or LED display rather, that gives me, as you saw earlier, a frequency displayer, but also I get up there fault codes as well and other messages, error messages, that tell me if the unit's got any issues. So if I ever have a problem with it, which fortunately so far, touch wood, I've not had, that's where I would go to look and see, do the preliminary diagnosis of what was wrong with it. I'm not going to go into sort of settings and things like that for this VFD because there's so many different VFDs out there and they can be set up in so many different ways. You'd have to consult the manual for your own particular unit, and me reading out a list of parameters for this thing, which probably wouldn't be any use to you if you've got a different one, is not going to make for a great video. So suffice it to say, here are the inputs and analog outputs and analog inputs as well. They're connected to the switches on the panel, and I've programmed this unit in such a way that it responds to those inputs from the control panel and the controls, and it does what I want it to do, basically. If you want to know a little bit more about how I did that, you can always fire off an email to me and I'll go into it in a bit more detail with you. I know Jack Body has asked me a few questions, and hopefully I was helpful to him in his VFD setup, and he managed to get it working, so that's good. Well, while I'm on the subject as well, Jack, I hope you've got that thing going well now. And congratulations as well, by the way, Jack, on winning the Double Boost monthly draw. I saw that you won that while I was at work, so congratulations for that. I hope you enjoyed your prize anyway. So that's basically what we've got with this in the enclosure, and I'll take you around now and I'll show you the back of the control panel, so you won't be seasick anymore because we won't be handheld. So let's do that now. Right, so I've unplugged the machine now, so everything behind here is completely dead. We'll take this panel off and we'll have a look in here. 2.5mm Allen key to get these mushroom head bolts out, much beloved of Harrison in their later years when building panels. You might be wondering why this panel's grey and not Harrison beige like the rest of the machine, and there is a very good strong technical reason for that, and it's got nothing to do with my nostalgia for the original Harrison colours. It's more to do with the fact that it was the only paint I had and I needed to get the panel finished. So yeah, I'm sure everyone's got bad habits just like I've got, but I guess one of the reasons is I wanted it to look a little bit different, so it looked like it was you know, a panel that I'd made myself, and I guess it does anyway. So anyway, enough of the excuses. So this is a little draper toolkit that my brother bought me. It's a fantastic little thing just if you're out and about doing jobs, or if it's the only place where you've got one of these things. And as you know, I've spoken about my brother before. He's got a great channel called Retro Mechanica, all about BSA bantams and restoring them. If you like the things I do, you'll definitely like the sort of stuff he does. He's got a lathe and a nice VMC milling machine, an Emco Maximat lathe, really great piece of kit. He does some great work, and he's just had a new engine come in, a D10 Bantam engine that's got a lot of issues. So worth a check out if you're into that sort of thing, or if you just like machining and general kind of amateur engineering. Yeah, so get yourself over there and have a look at what he's doing. We'll get this panel off now. We'll have a look inside here and see what's going on. I can't actually remember, so it'll be good for me as well. Right, come on you, off you come. Right, hopefully this rubber gasket's going to stay put. Right, there we go. There's a fair bit going on in there, so I'll bring you in a bit closer and you'll be able to see what's happening. Right, stay. Come on, play the game. There we go. Put it like that for now while we switch the camera off. Okay, so here's the back of the panel, and I have decided, in my less than infinite wisdom, that the best way for me to show you this is to do it handheld, so I can get any angles that I need to get without too much messing around. So apologies for the motion sickness that you may possibly experience while I'm doing this. So going from as we look at it from left to right again, as we did on the front, here is the main isolator, so that's the big Eaton switch. We've got the mains here coming in. I can touch all of this because this is completely dead. I've unplugged it. Here comes here is the 240 volt incomer with the live, neutral and earth that comes into the switch. And then from this switch we have two outputs, one which goes directly to the VFD down here, and the other one, this one here, and that is going to the single phase coolant pump via the switch for it down here. This one is the single phase coolant pump switch, so that's off, central off, and then on either side, just like the old one was. And then up here we've got our switch to give us our center stop and forwards reverse with the rapid stop that I talked about earlier. And this little unit down here is our relay logic unit, which gives us the functionality that this switch provides. This allows it to happen using the inputs on the VFD, the inputs that I had to do that in a fairly clever way, I think. You know, not to blow my own trumpet too much, but it does the job. And here is the tacho unit with its cables going off down here, and they go off down here to the tacho pickup, which is this cable here. And then we've got the various wires coming in. You remember the different colored wires from the back of the VFD itself. You see these coming in. You can just about see this connector strip down here, and that's where everything connects up to the switches through these red wires with the black tracer. The switches are all connected through this chocolate block. Perhaps not the best solution to the problem of connecting them together, but at the time it was all I could get, so I used it, and it's working perfectly well. Here is the 5 volt supply coming in down here through this small chocolate block, and that runs this relay module here and also is powering this tacho unit up. So that's coming from the 7805 regulator in the back of the VFD unit from one of the VFD supplies. And here is the jog switches. These two, they're connected up to the relevant terminals in the VFD via this chocolate block and these wires here. And here we've got the start button and the stop button. And this red circular component in the center here is the speed control pot, and I'm going to replace that because it's been giving me a few issues. Now these switches are industrial type switches, so this kind of chassis portion mounts onto the panel and then is clamped down with these screws that bear against the panel, and then this piece here, the actual switch piece, you can remove that and to replace it using this this kind of barrel nut type fixture here. So that's basically what's behind the panel. If you look down inside here, you can see these color-coded cables that are kind of coiled up. What they're for is the various interlocks on this machine. So there's an interlock on the chuck guard, which I usually have removed. There's an interlock on the emergency stop switch, the kick switch here. And those interlocks, there's also another interlock actually on the change wheel cover. This one here where you can see the 1 and the 0. That's another interlock, so that the machine won't run if the change wheel cover's off, because you have to have that in the 0 position, which then unlocks the change wheel cover. So all those interlocks are connected together in series, and I was asked this by Jack Body actually in his very kind email, if I was using the interlocks, and I am. They're all connected together in series, and they're connected in series with the emergency stop switch. So the emergency stop on this machine, on the VFD, is looking for a signal all the time, and when that signal is interrupted, then the machine is put into an emergency stop condition. So basically, if any one of those series connected interlocks is operated, then the machine will come to an emergency stop and stop in short order. Same as if the emergency stop button was pushed. I'm sorry, I've got a bit of frog in my throat today. So that's the basics of the panel, and that's how I wired it, and that's how it works. So there you go. That's pretty much the VFD tour of this machine concluded, and I hope it's been of some use to you. So what we'll do now is, I think we'll get the camera set up and we'll get this potentiometer replaced, and I'll show you a bit of footage of me doing that, I think. Right, let's get this old potentiometer off. I've got the heat shrink sleeving pulled back. Cut it with a Stanley knife first, or a small craft knife actually. So we'll get this desoldered now. I've got my glasses on, which nowadays I have to wear when I do anything like this. So let's take, this is the wiper, so we'll take that, we'll tuck that down there, so we know that's the wiper. And it doesn't really matter which side these go on, I can just position the potentiometer. These are the 0 volts and the plus 10 volts supply from the VFD, which is an analog input, analog output rather. The voltage, the 10 volt, then goes into the analog input of the wiper, and that gives us our speed control. So I'll just get this new potentiometer. So this is the one that's going in, and I'll just reposition you now, so I'll tin this up and you can see me do that. I think you'll be able to see me do it anyway. Yeah, do it on this, my granddad's stool, which is going to be my makeshift workstation to tin this thing. So this is a 1K potentiometer. It actually doesn't matter too much what value this is, because at the end of the day all it's doing is taking that 10 volt supply and splitting it to give us a varying output voltage. As long as the current parameters are correct and we're not getting it to sync more than it is physically capable of doing, which we're not, we should be fine. So we'll get this soldered up now and we'll get it mounted to the panel. So I'll take you back round. You're on the magnetic mount at the moment, which is quite handy actually, because you're on the side of the lathe. So let's get some heat shrink sleeving on these wires before we actually solder them on, because as I have discovered many times in the past, you can't put it on after you've soldered them on. And I think we've all done it. So that one was the wiper. Put that down there for now for safekeeping. Let's trim these down a little bit actually. I'll just get a pair of snips and trim those down. Slightly long, the conductors. Right, where's my good snips? There they are, they're on top of the machine. They were on top of the lathe all the time. Right, surely there must be people out there who are as absent-minded as I am. I certainly hope so anyway. Not for their sake, but for mine. Right, so heat shrink sleeving on before we start soldering. Let's get, so these wires are already tinned, so they should just go straight on there, I would have thought. There's the moment of truth anyway, we'll find out. Come on. There we go. That's one on. And that one was the wiper. This one is the other supply, or the 0 volts I think. It's fiddly, isn't it, this? You need to be an ambidextrous octopus, as I believe I said at one point. Yeah, I know, I probably could have done this a lot better, but there you go. This is how I'm doing it. Right, that's that one on. And now let's get the wiper on. Years of doing this have made me into a human vice. Right, here we go. A human den of vice, maybe. Right, that's the wiper on. Okay, so we're electrically connected, solder-wise. Let's get these babies on. Let me just get my, I seem to have put that on anyway. Can't do any harm, can it? Managed to gain a third piece. There you go. Right, or a fourth piece even. Right, we'll get the heat gun. We'll get them on. Why didn't I get the heat gun out first? Because I'm a numpty. Okay, where are you, heat gun? In the drawer marked heat gun, oddly enough. Oh, this must be riveting to watch, mustn't it? Eh? You lucky people. Right, here we go. Right, that'll do. That'll do me. Anyway, soldering irons unplugged, heat guns unplugged. Right, let's get this on the front panel. Now it may surprise you and interest you. I don't know, actually. Either way, let's cut that tab off because we don't need it. The locking tab. It may surprise you to learn, as it did me, that the thread, this is where I find out it's not going to fit, the thread on a potentiometer is in fact, not the thread rather, the nut is 1/4 Whitworth. I never knew that. So there you go. Who knew? Certainly not me. Underneath there, I think. That's it, yeah. Right. Yep, it goes. It's in. Okay, right. Not touching anything. No, that's good. I think it isn't anyway. Yeah, that's better. Right, let's get the nut on the front. So yeah, 1/4 Whitworth. Who'd have thought it? And I happen to have here a 1/4 Whitworth double depth socket. So that'll do to tighten it up with. That should do it. Right, that's not going to go anywhere. And let's have a look. It looks okay. No, I'm not too happy with that actually. Oh, it's kind of touching. Right, that's better. There we go. The joys of tightly wired panels. Right. That's okay. So I'm just going to put this in loosely and we'll give it a shot, make sure it works. Oh, I've scratched my paint. That's no good, is it? Right, let's get the erstwhile control knob on. Right. Like so. Something like that anyway. Right, I have to try and get it round there a little bit more. Do it the hard way, why don't you, Carl? Right. Right, that'll do. Try and get the range of it. Right, that's better. Let's give that one a nip, and we'll call that good. Where it is there, a little bit eccentric, but it's okay. Right, I'm now going to test this, so I'll do that off camera and I'll show you it once it's working, just to save my embarrassment for wiring the potentiometer up wrong. Okay, so 2 screws in to hold the panel in place. We've got power back on. Let's reset everything, switch the machine on, select it to run forwards. There's the chuck. Okay, here we go. Revving up my lathe. Okay, so there we are. Functionality has been restored. So the next job is going to be to sort out the tacho pickup. So we'll do that next. Power off. Capacitors. See, remember what I told you? Watch it. Long time, isn't it? That's why you got to be careful. Okay people, so that's it there. I'm going to call it at this point and publish, I think. And that'll be a decent enough video for you guys to watch. I hope you enjoy it anyway. And I hope you liked having a look around the VFD setup on my machine and watching the slightly cack-handed potentiometer replacement, which is all good now. I'm not going to do the tachometer pickup today. I just don't have enough time. I've got to pick up Harry from school and take him swimming, so I don't have the time to do that. I'll do that tomorrow and we'll put that out as a separate film. Now, it's international, no it isn't, it's National Engineering Day today in the UK, which is fantastic. So if you've got children of your own, maybe you've got a workshop, get them out into your workshop and get them doing some engineering type stuff today for get them inspired, get them hands-on with some tools and having a go at doing some stuff. And let's inspire those engineers of the future. That would be good. Now, since I got back from work, I'm very, very pleased to note that another 38 people have come along and have subscribed to my channel. So I'd like to say thank you very much to each and every one of those people. And I'd like to ask you to do me a small favour as well, if you could. If you're not subscribed to this channel and you're watching, please do so. It'll really help me to improve the channel and to make things better and to put out better films. And it's very gratifying for me as well when people do subscribe and they're interested in what I'm doing. And I hope it helps you, I really do. That's what I'm doing this for. And if you can as well, do me another favour, is give me a like. Click the like button below the video, and that will bump me up in the YouTube stakes in terms of people getting things like recommendations. So that'll bring me to more people's attention, and hopefully I grab a few more subscribers that way as well. The other thing to do, if you are subscribed, is to click the notification bell, because then you'll get to know when I put a new video out, because it has come to my knowledge in the past that there are some people that just aren't getting the notifications. So if you click that bell, then that should happen for you. So anyway, I hope you've enjoyed this one. It's good to be back. It's good to be back in the workshop. Good to be back to talking to all of you people. You make it for me, so thank you very much. And I will see you on the next film. Take it easy, everybody, and see you soon.